data platforms, and hopefully we're going to share some challenges in building them. My name is Priyan, and I come from a different background, a mixed background of a programmer, operations, and also recently more of a hands-on solutions architecture. I've worked with different programming languages, Golang, TypeScript, Python. I've worked with as a Linux admin way long time ago, and recently in the past like 5-6 years I've worked with AWS.
My name is Christoph. I'm a founder of Kodlot. I have a background in software engineering, recently turned into data and cloud engineering, focusing on building data platforms on AWS. And recently, last 2 years, I'm a technical lead also. So also a bit mixed background, focusing on data platforms on AWS, so relevant to the topic.
Great. So let's get started. Today we're going to talk about, we're going to start with an introduction about what data platforms are, and then later we're going to share some challenges, and later we're going to wrap up with a summary, and hopefully if we have time, with maybe 1, 2, or even more questions. Great. Let's get started. You might have heard data is the new oil, and you'd say, okay, we're storing data in our relational databases maybe, or non-relational databases, and we're having even access logs of all the different types of data we have. But how can we benefit from it and have value to our organization? Maybe by using AI, machine learning, all these fancy terms, right? And then you search a bit and you see this. This is the current landscape of machine learning, AI, and data in 2024. And at this point you might give up, but you think a bit more and you say, I've heard about this thing called cloud, which is going to solve all our problems, right? Then you search a bit again and you see this. Hundreds of services, of course, like hundreds of services, and this is just AWS, one of the cloud providers. If this is something that you're familiar with, and this is something that's happened to you, good news, you're not alone. Today, we're going to talk about a story about a hypothetical company around sustainability that was founded by a technical founder named Lisa, and she created an MVP to help solar farms perform better. She started with the MVP, you see this beautiful solar service, and then after that, when the company grew, she hired a CFO, the finance department, later HR, sales, and so on. And of course, with the new trend of microservices, they said we should also have microservices, right? They created a new one, started to extract certain different like logics from the application, extract. But then for this talk, let's focus only on a simplified version of it, and have like the core service, sales department, and supply chain, like services around this area. For example, the core service in this scenario, we're ingesting panel failure a stream of panel failure, and also we're calling an API to check what is there, or even their forecast for that day. Sales, we're using Salesforce, and we're also storing a copy of the customer's data in a local database, relational database. And also supply chain, initially we're having suppliers data and inventory data all in one relational database in 2 tables. Later on, of course, with the microservice architecture, they split it into 2 services. At this point, they started to realize all these different parts of the organization have to talk to each other. And they started to share data in around the perimeter fashion. Everything was good. Everyone were happy. Lisa at this point hired like Tom, a data architect, and asked him if he can help the organization figure out like all the data they have, if it is performing better, good enough or not, or if they can improve it. And at that point, Tom started thinking, but I need data, right? If I want to see if I can add value, kind of either with BI solution or whatever, any data. We looked around and figured out data was everywhere. With that, I want to hand over to Christoph to talk about what is happening next.
Thank you, Priya. And here we're going to start the journey of what Tom can do when it comes to defining the data platform to solve this problem. And as you can see, we have an evolution. So from the 60s, when we introduced the first databases, we are now evolving towards data warehouses. So where we storing the data in a relational way, we have structured data. Now the data lake, which is highlighted here, is when we are moving into the direction of storing maybe not only structured data, and that's the modern approach. Now we have the cloud-based data lakes, and then we have a mixture of those two in the form of data lakehouse. And then similarly, what Pujan said, we are borrowing from the software systems the concepts of decentralization, and as YQ presented, data mesh is the first kind of conceptual implementation of decentralization in the data analytics platforms. And what's next, we don't know, but for sure there is an evolution where we're going to see other patterns appear. So Tom has a fundamental decision when establishing a data platform. It can be centralized or it could be decentralized. So just to give a brief introduction of the centralization, kind of repeat the idea for that specific organization that Lisa is running. Data lake is a composition of a few components. So we have the ingestion part where we are doing movements of the data, transformations, cleanups. A few services that can help us with that are Amazon Upload, which is a no-code solution. We have Glue. We can even employ Lambda for smaller data volumes. Then, of course, we have to store it at Amazon S3. It's a industry standard on AWS where we want to store our data for analytics at the moment. And then we have three components which are helping us with governance and security here. Lake Formation is a prominent service helping us with that. But we also have IAM and Secrets Manager that are utilized in this space. Then we have the concept of lineage, how our data is flowing through the platform. And of course, the catalog that is the metadata around our data lake. This is data lake at AWS, the core components. For data solars, this means that we are ingesting the data into a central place. So all our data is stored typically in one account or in a kind of collection of buckets on one account, and it's available centrally to be consumed. As you see, all the data from data solars are ingested here. For the consumption, we also, of course, read from this central component into multiple use cases. We can have ML, we can do other types of processing, whatever we need to do. And just to give a bit more complex example in this ecosystem, we can flow this data from our S3 data lake on the left into various types of other data lakes, maybe warehouses like Redshift, but also streams with Kinesis and a vector search service like OpenSearch. And just also to repeat, we have the option to define our platform in a decentralized way with the first concept in this space of data mesh. As mentioned, we have pillars in this concept. It's like an architectural concept where we treat data as a product. So we have this concept of producers and consumers that is interchanging. We have the aspect of governance, which we want to automate. We want to define it for our different domains of our organization, so there is this domain-specific aspect of it. And we want to have our platform team help accelerate this transformation. So we want maybe not to have an expertise in how to manage the infrastructure all over our organization, but we want to have a platform team that is going to provide us some self-service capabilities. And with that, what we could do to visualize this for the concept of data solars is model our different departments, so like the core service of data solars, sales department, and supply chain as nodes. They will be like small data lakes. They will ingest data into their own space, into their own maybe AWS account, but then they can exchange this data. So with the data sources that they deal with, this is how it would look like conceptually if they have to ingest this data. We will have in this decentralized architecture a central component that could do cataloging, it could do governance, so that the data producers can talk to each other and know where to read the data from, what to consume from where. But the data is decentralized. Each of those departments own their data. It's not living there if it's not needed, if it's not defined through this federated conceptual governance, computational governance. So this is the basically core concept of data mesh. For this talk, we have thought about what challenges we would like to talk. We have a limited time, so we made a selection of topics that we prepared for you for today. So we're going to focus on data transfers, how the data is going to be moving into AWS, how we orchestrate the data transformation through our data platform, how we automate our data platforms using infrastructure as code, what kind of limits we can see when we are doing that at an enterprise level, how we monitor, what is the evolution of data, how we can handle schema evolution, and lastly but not leastly, security and governance, so how we make sure that people see what they need to see. And with that, let's start with the first challenge. Tell us about data transfers.
Great. Let's begin by the first challenge, that's the data transfer. Before I begin, I'm going to ask you some questions probably. We're going to ask you some questions during this talk. Whoever answers gets a gummy bear, and we all love, sugar. If your sugar blood is low, now you know what to do. So bear in mind, you have that chance. Let's begin. We all know probably, if you have worked with network, probably you know that the most unreliable part of any system is network, right? If something happens, the first thing you probably check is network. Oh, the network is down. And unfortunately, we live in an era that the network throughput is not unlimited. So we are bound to the throughput of data through any link we have with any type of sources we have. It can be either from this server to this server, this side, or it can be like from here to the US, right? So unfortunately, it's not bound. And these days, we're talking about multi-regional architectures. We're talking about reliability of the services, having multiple nodes taking care of it, different, like the same thing in an active fashion, to have probably 99.999 activity, availability. And also, there's something that we sometimes don't see, and we think network is free on cloud, right? But that's not true. It's not always free. It is sometimes free. For instance, if we talk about AWS, as a general rule of thumb, if you send data to AWS, it's free. If you send out, that's not free. But this, if you send data to AWS, this free thing itself is also tricky, because you might think, okay, everything is in AWS, so I'm not, incurring charges, right? But you have one, service in this availability zone, the other one in this other availability zone, or you might even have your own data center connected to AWS through a hybrid, infrastructure, hybrid solution, and all that you might use CDN, CloudFront, or even in some advanced architectures, you end up sending data outside of AWS data centers, and you pay network, and at some point you have to try to optimize that. Speaking of speed, if you, for instance, are like a regular, medium-sized company, you probably have 100 terabytes of data, and if you are lucky and have 10 gigabit per second of link between two, sources that you have, source and destination, then it will probably take a day for you to transfer this data if nothing happens, right? But imagine you have only 1 gigabit per second. That takes 12 days. Imagine you're a bigger company and you have 5 petabytes of data. And the same old cheap network name, it takes 2 years to send that data. If you want to send it over network, you might have some options. If you want to transfer to AWS, you might have options. But if you're already in AWS, that's also another thing. At this point, I want to see if anyone can guess. The first one who puts the hand up.
4 years.
No, you have to wait for me to finish this. If anyone can guess how many days or years or I don't know, like mega years, I don't know, would it take for 10 petabytes of data to be transferred over 1 gigabit per second?
4 years.
No?
No.
Anyone else?
10 years?
Yeah, you?
10.
No?
Are we talking on network?
500 years.
Oh my god, I love that. But that's not
If
true.
you send a person and transfer it in 1
If you're
day
saying
twice,
snowmobile that has been discontinued.
So it's 10 petabytes over 1 gigabit per second. So I'm gonna help you. 1, 2. Anyone can guess? We have 1 and 2, right? 1, 2. Anyone can guess? What is after that? You want to say? 3 or 4? 4, no. Anyone? 1, 2.
3.5.
What is the number after 2?
2.5.
3. Who said 3? Oh, much sugar.
It's not exact 3, right?
It's 3. It's exactly.
Exact 3?
I'm gonna see.
That doesn't end up.
3? Yes, it's 3. Great.
It's like
It was too, easy for you guys to answer. So we got the first winner. Great. At this point, you might say, okay, but we're a bank, we're old bank, we have data and a data center, and but we want to probably use AWS at some point to build our data platform, like a data lake there probably, because we don't want to predict for the next couple of years how much storage we should buy, all these things. And you might say, oh, but you have all the data in our data center. But that's not true. Depends on the size of data. You have different options. And there are actually multiple parameters. Like the most important thing is the volume. Depends on the volume, you either can migrate first and still depend on the volume and the other factor, or you can have about hybrid solutions. Like for instance, this is one of the examples. If it is not too much, then you can just have VPN over internet or direct link or whatever, and just use Glue to ingest and put it in your data lake. At the same time, you can even replicate it, have it on relational database or whatever. But this is just one architecture, very simple one. And with that, I want to hand over again to Christoph to talk about orchestration.
All right, thank you. So now we have the data in AWS, or we work with data in AWS, and we have the problem of moving it around. So Lisa then asks Peter, data engineer, to build some data pipelines to ingest from different sources, clean it, and store it in the data lake. And Peter is on it. Just to give an example of what data pipelines, or ETL as we call them in the data engineering world, are, this is extract, transform, load. And so you could think about them as like nodes in the graph where some compute is going on. And typically, if we build a big platform, we're gonna have a few of those. And once we start having a few of those, we will come into the problem of orchestration. So how do we make sure that the data is moving through our system, and if it's moving through our system, what else should be running after the data is moved or transformed or cleaned? We want to have a visibility to monitor it. So typically, we will want to orchestrate it. And in order to orchestrate it on AWS, we could have a help from a service of Glue, which is a base service for any kind of compute at scale. It has the serverless Apache Spark engine, but also there is a Python shell which is going through a deprecation, and Ray has been recently added. So we have a large compute available, but we also have the concept of workflows where we can have these nodes of our pipeline defined. And this is pretty good. We can orchestrate different components of Glue, like jobs and crawlers. We're not going to go into details of those, but those are the two basic resources of Glue. But when we want to scale our platform, we then want to maybe use a tool like Airflow, which is then natively supporting also Spark, but also tools like dbt, maybe Hive, Kafka, and also Glue. It has the easy way to manage your DAX and connect to those different data sources. And then maybe also question from my side at this point: do you know what's the service on AWS that can help you use Airflow in a managed flow?
Isn't it just called AWS Managed Airflow?
Managed Airflow
Service?
service? Okay, I'm gonna give two. These are one here, one here. It's close, close enough. So it's MWA, managed workflows for Apache Airflow. So through this service, you define this environment, what it's called, where basically the entire Airflow is going to be provisioned for you, and you can basically use it out of the box. So in this way, we can do orchestration at scale, where maybe we have more talented people already used to a tool like Airflow, and with the Glue workflows, it's a little bit more AWS specific. Here we are kind of open to a broader community. So this is the topic of orchestration. Now let's maybe take a look at how we can define our data platform through infrastructure as code.
Perfect. So like any other kind of IT project, we probably start with an account, POC. We create some resources probably through console, and then later CLI, it's fancy. And I want console, and we have everything. At this point, we just say POC, we throw it out, right? But no one throws it out, right? We just rename it to production. Is this something familiar to you guys? Anyone have faced that? Put your hands up if you have just renamed POC to production. No? No POC went to production? Great,
I've seen people do it, but I've never done it myself.
Great. We have seen it, at least we have seen it. And at this point, we have done everything manually, right? So, but the thing is, what if I add new changes? We probably need to have some sort of regulated environment for someone else to look into resources and see if it works or not. And then we have to do everything manually again. And then developers come, and then we have multiple developer accounts. We have to go through a list, do all these things, staging, all these things. Who wants to do that, right? And we have this concept of it works on my environment now. It works on my dev account. It doesn't work in production because I forgot to add this permission, IAM permission. Oops. So that's something people have to experience. And that's why we have CI/CD pipelines. The CI/CD pipelines, we probably in the application world, we build, we test, and in infrastructure world also we can test, but if we test, it's another thing. But we can also test, at least what is going to be produced to our production, and then deploy. We started as configuration management as code, for instance, things like Ansible, Puppet, Chef. If you are working with field for more than 5 years, you probably have worked with them a lot at that time. And it was we have a VM, we push the configuration, we hope things are gonna be there. But then we Terraform, we start to have state to make sure whatever you define is gonna be in production or whatever environment. And then alternative for AWS, CloudFormation, we all know, we all have used it, but the problem was that who doesn't want to work with YAML or who doesn't want to work with HCL, right? It's if you're a developer, you don't like that. It's a different thing. Your IDE doesn't work with it. You cannot reuse. So then we have this thing called infrastructure as software. Things like Udemy, which is similar to Terraform, is can have multiple providers, different cloud providers, even your GitHub account, and stuff like that. Or the AWS alternative specific called CK. You can use the power of your IDE, you can reuse code, you can have logic there. There's the date, should I add logic or not? In here you can add logic, you can test it. And then later on, if you want to make sure whatever you define goes the way that you think you should go, you can either write, for instance, unit tests and say, if I have this logic, will I produce this code that will produce this resource simply by writing the unit code, unit test. You can even go further and write snapshot testing and see, okay, but what actually we're going to go there? What is that? Like, I want to make sure whatever stack I build, the changes, I want to see it in a pull request, even before everything. I want to see it. Then you can enforce people to update the snapshots, and even by just looking at the pull request, you can see, okay, this is going to change, for instance, this port number to that port number if I merge these pull requests. And this is just an example. We can apply to everything. And that's for infrastructure as code. And with that, I want to hand over to Christoph again to talk about cloud limits.
Thank you. So now we are starting to scale our platform, and we will see that we will have different kind of limits applied to our case. And today we're going to talk about a few of those limits. One of the ones that you're going to discover pretty fast is service quotas. But we can also have limits that come from our infrastructure as code tool. We can have API throttling. The resources are not infinite. And then maybe some soft limits like legal, knowledge gap, and cost. And at this point, let's discuss these cloud limits through an example. So our CTO says, we want to build a scalable solution for data ingestion from SaaS sources using no-code no-code AWS service. And Anna, our cloud engineer, is on it. So what Anna does is tries to map the challenge. And the challenge that we have is that we have SaaS providers. Here we have multiple Salesforce instances that we want to ingest the data from. And we have also Adobe Analytics and Google Ads campaigns. And as you see, we have 3,460 objects to ingest from those SaaS platforms. And you might think this is very easy. We are on a very kind of powerful environment. There is not a lot that can go wrong. So let's see. We are using this service called Upflow, which is a no-code solution. So we just point this Upflow to a Salesforce instance, and in this case we have a cases object on that Salesforce instance, and one flow is ingesting this one object into S3 bucket. This is one resource of this Upflow service. But then you will see that we will have this service quota limits. So what we can do is we can have 1,000 flows defined on an account. We can run 1,000 flows in parallel. We can only define 30 flows in parallel at a given time. This is our API throttling limit. And then 100 gigabytes of data can be ingested is advised by AWS to ingest through that service. And then to give an example of infrastructure as code, how we can solve this, let's use CloudFormation. CloudFormation has its own limits. You can have 500 resources in CloudFormation stack, 2,000 stacks on your account, 3,500 operations in parallel, and your template can be 1 megabyte in size. What you're going to see is that some of those limits can be adjusted. So you can make a request to AWS and say, I want to have more than 1,000 flows defined on my account. That's going to be granted. You can do it. So 2 of those limits go away. Similarly, for CloudFormation, we have also these soft limits, which we can adjust. And the problem is solved. But as you see, not all of those limits are soft. Some of them are hard. And then in this case, we have to think a bit about our solution, how we can overcome this problem. So for CloudFormation, let's just introduce the concepts because we need them to make this solution. So we have with CloudFormation this concept of stacks where we define our resources, and stacks can have what we call nested stacks. So the stack is itself inside the stack, and then it has resources, and resources can reference each other, creating these dependencies. So we can define, for example, Lambda function in stack 2, and it references MVPC in stack 1, and then we have this dependency between the stacks. So when we define this solution, stack 1 will have to be deployed first, and stack 2 will then follow. Otherwise, it's not going to work. And CloudFormation can figure out this deployment order. So now let's say we want to ingest 700 objects from one of those SaaS platforms using Upflow. So what Anna can do is define one stack and put 700 resources into this one stack. But then you see we're crossing the limit of 500 resources per stack. We're crossing the limit of 30 API calls we can make. So that's not going to be a good solution. One approach that we can do is we define this stack unit. So stack unit is where we have 30 resources, and this is kind of our deployment unit then. And this is going to work because all of those resources might be created in the same time, but our limit of 30 resources is not breached. So we're good, but then we also have to overcome this limit of 500 resources per stack if we want to ingest 700 objects. That's when we then model our entire solution to be composed of those stack units, and you see that we have 24 stack units, and each of them has 30 resources. This is not going to be a problem because we have only 24 resources. Each nested stack is treated as one resource. So the limit of 500 is not reached. But the limit of 30 flows created in parallel is breached. And can anyone tell why is that? That's going to be a word.
Because a stack contains 7, and if you have 5, it's 35.
Each stack unit contains
7.
30.
Ah.
It's parallelizing the different stack unit creations, right? They're not happening in order, they're happening in parallel, so you're reaching that.
Very good, very good. And you have one, but maybe you want to give it to someone, but that's a good answer. That's a good answer. So what we have to do is we have to force this dependency. So what we can say in CloudFormation is that one stack depends on another, and what we're gonna do by doing that is we're gonna make this whole deployment slower, but effectively stack unit 2 is only gonna start creating when stack unit 1 finishes. So we're going to extend the execution of this creation, but we will not have any deployment errors. No API throttle. All our limits are checked. So with this idea, we can then model our whole challenge to be composed of 5 top-level stacks, each containing different amount of those units, depending on how many objects we want to ingest. And this is a solution that is then going to scale. But what we can do to make it a step forward is we can introduce this concept of configuration file, where our data engineering team can say which objects we want to ingest from which SaaS platform, and then with the help of DynamoDB lookup table, we will know where each of these flows is deployed. So if we remove something from the configuration file, we will then be removing something from one of those stack units, and then we know we have a gap, and we will be able to fill this gap because we will know where in the future, if we need to create a new flow, we know where we have a gap, so we can fill it in. So it's going to scale without introducing any gaps, and that's a solution that is working with one of our customers for more than 2 years, and it's scaling now beyond 3,000 flows where we can create it without any errors. But then when we talk about limits, we also sometimes have to give up. So when Upflow has to ingest something of high volume, then we maybe have to switch the service and use Glue, use the help of the managed Spark, and that's also fine. That's part of our architecture evolution, that we have to make those adjustments. We cannot work around through all of our constraints. That's just how it is. So now we managed to scale, overcome the limits. How can we monitor our solution?
Great. Now that we have already deployed our solution at scale, and also we have deployed also our orchestrated our pipelines, let's see what else we can do in reality on a daily basis. As once the CTO of Amazon said, everything fails all the time. That's the important thing, and we should always take a look at what is happening and be ready for it. There is nothing set in stone about how to monitor stuff, but there are two practices in here on where to do metrics. One of them is the use practice by Brandon Beck, and it says if you are monitoring any resource, which is like, for instance, a VM or limited storage, stuff like that, then you probably better put metrics on utilization, saturation, and error rate. On the other hand, if you have workers, like for instance background jobs, or for instance an API, then you probably want to use the red method, which says let's put metrics on request rates, error rates, and duration. This is not set in stone, but this is something that has worked for many years, and that's why it's being used most often as a best practice. Okay, now that we have put metrics, it's convenient to put alerts on everything, right? And send it to everyone. But then after a while, you see people like, this is not important, this is not important, and we miss the important ones. So it's important not to put alerts on everything, and not to send notifications to everyone for everything. That's a very important thing. So what should I put alerts on, right? It's, as a best practice, it's better to care about what is good for the business continuity, does it have any business impact if something goes down? And does it have any effect on the user experience? If something goes down, can they still continue their work or not? Then it's better to put alerts on these things and send it to people who really are important to receive that. And with that, I want to hand over to Christoph again to talk about schema evolution.
Great. So our platform is live. We have it in the codes. We are monitoring it. But then we're going to see that we have errors because our data is changing. We have this concept of schema evolution where actually it's just how it is at the source. Something happened to the definition of the data. It's evolving. What can we do? First of all, we can detect that something happened. So we have this article from AWS presenting us with this architecture proposal of how we can actually identify that we have a schema change in our system. And with the concept of glue catalog table versioning, we can see that we have different versions of the table we can use. We can tell our consumers, look, we have a new version of the table. It has different schema. Please adjust if you are ready. But this is just kind of the beginning of how we can handle it, the notification part, and then we need our consumers to adjust. But with the open table formats that was introduced by YQ before, schema evolution is one of the advantages of those formats. So together with other advantages, those formats are able to evolve and are able to have this feature kind of built into how they are processing the data. So this is something that we are now investigating, and we are transitioning one of our platforms to use Iceberg, and we are learning how to use this format. So it's going to be simplifying our life, and especially in the long term when our platform is really living for many years. And with one of those formats, Iceberg on AWS, we see quite a lot of adoption. We see analytical services like Athena, EMR, Glue, Redshift adopting it natively. So we can start building the solutions that are taking advantage of these formats kind of on a large scale. And with that, I'm happy to hand over to Puya to talk about how we can secure and govern our solution.
Great. Last but not least, security and governance. At this point, if you have already remembered this company called Data Solars, the CTO comes and says security is #1 priority from now on. She hires a DevSecOps engineer called Brian, and he starts looking around to see what needs to be done from the data point of view. The first thing, when you store data, you probably need to encrypt it. AWS provides ways to encrypt, but it's our job to make sure that we encrypt. Nothing magically happens. We should make sure that we encrypt. If we transfer important data, we should always be able to make sure that we encrypt data in transit. And if you are dealing with sensitive data, it's very important to make sure we decrypt and encrypt before the data is being processed. If you store data on S3, AWS provides a service called Amazon Macy. It's managed email-based service that you can point it to your S3 buckets or buckets. You can define what bucket to look into, and then it will look into it, and it will, based on some pre-trained like formats, it guesses if it has PII or sensitive data. It's not 100% accurate, but it's good enough. And it depends, like charge-wise, like cost-wise, also it's important to make sure that if you're dealing with large volume of data, make sure to do the calculation. Otherwise, it might be very expensive. You also have this option of using Amazon CloudWatch like data protection or AWS Blue Data Blue to either detect or mask. And on the application layer, also you can use Amazon Comprehend to see if the user has sent data that might contain PII, and you don't want that your PII to end up in somewhere that you're probably sharing with, to detect and do something about it, either mask it or do something. And also you can use Amazon Redshift dynamic data masking. But how about data platform that we have? Before answering that, let's see why handling, like managing permissions on data platforms is hard. We talked about data lakes, but in a simplified version, data lake is basically nothing but just a storage, like a detached storage and data catalog and some sort of analytical engine that does the analytics, like query based on what metadata you have in the data catalog from the data that we have already stored on S3 on a simple level. And then you might, we usually handle permission in different ways for all these things. Like for instance, on S3 you might use resource policies. For the data catalog, you will use IAM policies for the user to see who accesses to what. And for the analytical engine, you configure the engine to work with the data catalog. And at the same time, you configure IAM policies for the user to access the engine. And even thinking about all these different ways and synchronizing all these things, we know that it's not easy and also it's prone to error. So what can we do? Fortunately, AWS provide us with a service called Orchestration, and with that we have two ways of defining these access controls. And they are usually being used at the same time. We have the resource policies for the more like generic ways to say who accesses to what like buckets, and then we use type-based access control to have like more granular access and define like who gets access to what row and what row and what column. As an example of, and how does it work? Basically, the administrator registers the location, sets up permission on resource. When you query these services, first administrator check the authorization with lake formation, and then with the credential coming back and with the scope defined there, it defines what kind of data you have access to the resource on a S3 bucket. And then based on that, these tools again use that to filter out what you're not allowed to access to. At this point, you might say, okay, but a few scenarios. You might have like new employees coming to your company, haven't had their clearance yet. It's a banking, it's a very important thing, and they should not have access to sensitive data or even PII before they get their clearance. Easy. For instance, Tina, new employee, she joins the company, the administrator uses the include exclude list to just mask everything except the number fixed in this scenario, which is something that is not PII, it's not important. And at the same time, we might have Marianne from the BI team who should have access to everything except the sensitive data. Similarly, with the same technique, we can just mask the credit card information for her. And another scenario, we might have Alex from the Danish sales team who should have access only for the customers in Denmark, but no sensitive data. This time, we can use row column filtering, and for that we can just and it's easy. You can use like a particular QL format, which is like if you have worked, for instance, with DynamoDB, is the easier format of dealing with DynamoDB compared to the API one. It's the same format. With that, you can define like to what row and to what column who should get access to. And then at this time, Brian says, "Oh, I just realized you're processing credit cards. Don't do it. Just a side note, don't do it if you can avoid it. Don't do it. We don't want to deal with credit card if you're like not a credit processor company." But in this scenario, they're doing it. He says, "Yeah, I realize we should be PCI DSS compliant, right?" And the CTO says, "Okay, I'm gonna see what's the business point of view. Can you see from the technical point of view what can be used, to even figure out how far we are from PCI DSS compliant?" And fortunately, AWS, we can use AWS config with conformance packs. They have some, in there you have some pre-managed ones. You can have your own conformance packs, but also you have managed already in there, conformance packs either for PCI DSS, HIPAA, best practices, like there are many of them. And then if you apply them, the good news is that you can even have access to the history. See like, oh, 6 months ago we were not, you're like 90% compliant. You didn't have this kind of compliancy, but now, good news, we have it. Or even you can go one level further and you can automate remediation actions. Like if something happens, we want to be compliant, right? And then you can automate if someone like this guy, like Guyan, I don't know, creates a new volume and doesn't apply encryption on it, just destroy it or stop it or whatever. You can apply it, but you have the option. And with that, I want to hand over to Krista to wrap up with a summary.
Thanks a lot. So we had quite a few things that we covered today. We tried to select the things that we believe are good challenges that you're going to face if you want to build an enterprise level data platform. So we start with bringing the data into the cloud. We can of course do it from on-prem or different data sources that we have. Then we have a challenge of data transfer. We will have to move the data around. It doesn't matter what's the architecture that we choose. We will have to orchestrate when we are at scale. Hopefully we're going to imply infrastructure as code or infrastructure as software depending on our platform, data platform team toolset preferences. We're going to hit the limits, so this is where we have to be creative to come up with solutions that overcome those limits, and it's good for cloud engineers to be aware of those limits, to build solutions that can scale to avoid them. We will have to monitor, that's a very big challenge. We will come into the problem of schema evolution. That's just inevitable. The data will change. And security, job zero, governance is the pillar of data mesh. We have to take care of it. This is a foundational aspect of building data platforms. So the key takeaways that we would like you to take from this talk is that we are in a complex landscape, both of technology and tooling. As Guyan presented, AWS has more than 200 public services. It's probably impossible to comprehend what they do, how they can help us. So we need to collaborate with a lot of people and gather that information from each other. We are evolving, so we probably have to think about the long-term vision. If we want to be centralized, if we want to be decentralized, maybe try to avoid the hypes, but also think about what are the benefits. If we're in an enterprise level organization, data mesh probably makes sense, but also it has to be implemented in a rational, there has to be a vision behind it. And then at scale, there are those challenges that we mentioned. So you have to be prepared for them. There is probably more than we didn't have time to cover all of them. We prepared a bit more, but the time constraint was on us, so this is what we selected for today. And with that, we will be happy to open for questions if you still have energy, or if you have any.
The
compliance? If you, for example, use like Stripe or something like that, and how much of your compliance goes to them? Like your, is it if you got, for example, use Stripe and your, I'm not sure how it would work, but if you did use that, then would that reduce your compliance requirement?
So the thing is, if you process like credit card information, you should be PCI compliant. But when you use, for instance, PCI Stripe, then nothing goes even into your code. So the thing is, you will get the token. You won't get any. You won't even see any credit card information. You will see a token that okay, this thing, whatever that I'm waiting for it happened through this token. And if it happens, you say, okay, whatever transaction I was looking for, that we send the data. We say it should be like 30 Danish crowns for this user, blah blah something, and then take care of it. The user will enter the credit card on Stripe, not on your website, on your site. Even if you use the elements, for example, in Stripe, if you use elements doesn't send it, you cannot interact with it. It sends it directly to Stripe. So you only get like a token or something, and you don't see any. But if you see it, you should be PCI compliant. That's the truth.
So it's better to just outsource this.
Exactly, unless you're a payment gateway or a payment processing system.
So these compliance packs,
Conformance.
conformance packs. So can they also be used standard, or do you need to kind of buy into this entire security platform?
No, the thing is, like, it's a part of config. You need to first enable config, and then how it works is that config basically knows what kind of resources you have. So it listens to CloudTrade and sees, okay, this API has been called. That means like whatever, like that user has created this resource. So it keeps the history of what resources with what configurations have been created, and based on that, it decides, okay, this resource, is it compliant with what I expect or not?
How does it compare to services like Control, Kubernetes? Is it roughly the same? Or? I think there are other like security tools, like I think it's called Nessus or something.
I don't know.
Actually, there's that.
It's an AWS specific, so might be very sensitive. I don't know about that tool. That tool might be not like some generic, but I don't know.
I think it's nice that we enable config also. So.
Since you mentioned data mesh, and in the book data mesh recommends that the unit of scale of the architecture is the data product. In your experience, is it a realistic unit of scale, or do you scale your architecture by teams or domains?
That's a very good question. I think we haven't yet implemented a data mesh in our project. So this is something we are missing on an experience level. We see the evolution of services, and we see how people talk about this concept with the AWS talking about data zone and how the tooling is starting to help with this architecture, but at scale to have an experience where we say like we enabled, I don't know, 10 departments to be really in that concept, that we don't have that experience to be able to guide on that level. Yeah.
Regarding the mesh as well, I know you say that you haven't implemented one, but I don't know what would Fiori say. So the mesh is expected to be distributed, right? What would be the scenario, the best scenario for you when you have like a mesh distributed in multiple physical regions, let's say, where data has like a regulation, like let's say GDPR, and the quality of how it distributed is also to reduce costs. That's why I understood, and also like to have like a easy way to manage data and just populate or merge from different legs, right? So wouldn't be an issue if, for example, the mesh that you have will only be able to access data within the same region, let's say. So So if I have an office in USA, will not be able to access all my personal data in Europe because GDPR, for example. So it would be like removing the whole idea of the mesh.
Yeah, so this is interesting. Also talking about limits, it's a legal constraint generally about the cloud system, but this is where we have to cross this mesh concept if it really makes sense for our organization, because I can see that the main advantage of having this mesh is we have domain expertise within each department. So the main benefit is that we will have the people who know what this data really represents, working together with data engineers, data scientists in each of the departments of our enterprise. And this is the main benefit that this decentralization brings. If we have a constraint that our organization cannot work for GDPR reasons within certain regions of cloud, I don't see that as specific to data mesh. It's more specific to how you're gonna architect your solution, which regions you're gonna utilize, because maybe your departments have data systems outside Europe. It makes sense to bring compute close to data, as YQ said. This is the gravity of general data platform architecture. It's not specific to data mesh, but if we want to have each department processing their own data and they have data outside Europe, that's another topic. Maybe we have to do data transfer and transfer this data to another region inside Europe to be compliant. Yeah, it's not, I don't think it's specific to data mesh architecture. Yeah?
I have a question regarding the schema evolution. So, like, there's an X amount of services that can run schema or transfer of data. Some of them can mention this, like Kafka, do have or impose some restrictions on the way those evolutions will be taking place. So, in your work, do you see any challenge about saying or telling to the business, well, your schema can evolve up to that point where you can, change that field, change the data type, but if you want to go beyond that, like, where is the business logic, the business decision, where is the technological leverage? So you can use when it comes to streaming, you can use it and it does it pretty well, but at some point it has its limitations. So did you reach some point where you had to do a compromise on that?
That's a tricky question, yeah?
Yes.
So it's a tricky question because schema evolution is maybe not something necessary that business is really caring a lot about, as long as you have the fresh data in your system going to the consumers. So, schema evolution is an implementation detail in a way for business. They will not really care so much about that something has changed internally in one of the source systems. So, unless the data is not there. I'm not necessarily have a good answer here. Yeah?
I would argue that this problem is smaller today than it used to be. Because in this approach, you tend to treat the sort of analytical queries that rely heavily on schemas. You push them to the edge, and you sort of versioned data in another place, so you can create separate views. So if you have, like, at a certain point, you can sort of have a split in your data pipeline. So you can say, we need to keep supporting this old version, but now we have a new version, so we're just feeding into two separate data products that serve slightly different purposes. And as we saw in the previous talk, that might literally mean that you have two, like, Redshift views running on the same underlying data. So you may not even have a physical copy of your data, but you may have two completely different schemas running on top of it, providing different views for different use cases. So it's still something we need to deal with, but because there's not just a single view of the world anymore, we are kind of pushing this to the boundaries of our context and, like, don't have to worry so much at the core of where we store the data, if that makes sense.
Yeah, I mean, I was going more for a data object model, so we don't have a as important implementation, because as soon as you talk about views, you're lowering the implementation. And it's like, how do you abstract it? Because, I mean, as soon as they see data moving faster, the business kind of starts being happy, but they're not like, suddenly they get used to the new status quo and start the data. It's not like adapting the business model. Yes, eventually the schema. So how does it, the whole shebang gets abstracted so they don't get restricted at some point and they have to do those splits and whatever. So is this a discussion from the get-go?
I think that is part of the reason when we talk about data products. Because if you have consumers of your data, you need to treat it as a product. So you cannot just break your schema because you have users of your product. You cannot just break the contract you have with the users. That's the same as when you provide an API to microservice, you need to think about versioning, you need to think about backwards compatibility, and so forth. And that means that likely if you manage a successful data product, you will have different APIs, different views, different whatever ways of interacting with the same data. That's I think where like the product thinking comes in. You need to always consider the effect on your end users, because there are end users. If the data that you're working with is important, it has users.
That's my point. Actually, I think we're flipping the conversation. Because the data, when doing the contract, it's supposed to be a mapping of the business requirements, what brings value. We're not discussing, it's not the infrastructure, it's not the companies, it's the business that does the revenue. So that business, how it gets mapped to the actual, all the way, I mean, I won't say lineage, but how does it get mapped to the underlying data representation? And with that evolution, when it starts to evolve in time, how does this get abstracted? Because at some point, you cannot do the change anymore in a way that the business is really willing to move forward.
I interject a little bit. I think you might referring to general idea of data modeling. You might have a conceptual model going to a logical model or a physical model.
Yeah.
Right. You sort of start with like balls and arrows on the whiteboard, and you'll get to like SQL tables and form key constraints. And he's talking about the upstream conceptual model, the business model, which is ultimately the data model, not the physical data model, but is sort of how they want to talk and ask questions about data, how that can evolve. And so maybe we wouldn't call it schema. Maybe schema is just like it's just is this an integer or is it a varchar or is it a floating point number versus like what is a customer?
And what we think about schema evolution when we think about it is on a data lake level where we have this data catalog. This is our thinking, like not necessarily on the business side. We're not thinking yet about data products maybe, but we have consumers of the data lake. We typically maybe go through data warehouse that does some processing on top. It doesn't matter where it is, but there is evolution on different layers. Yeah, so I think this is a discussion that has maybe a few subcategories, but general problem, where to handle, how to handle. What I see is teams have to come together to talk. Those teams that are on both sides, yeah, producers and consumers, and they have to agree how they're gonna handle that. I think with this open table formats, those are the tools that are making this transition maybe a little bit easier, like seamless. But still, it is not necessarily, it doesn't mean that it's not kind of not seen, because something is changing. Yeah? Like new columns are there, there are updates, maybe that means something to our values that we read. Yeah? So I think it's a very interesting challenge. That's why we put it here, that we not necessarily have answer yet how we would be approaching it in a general sense. I don't know if you want to have more questions, because we are approaching Denmark game today. So what's your energy? If there is 1-2 more questions, we can take them. I might think it might be illegal to have the game by Denmark as a game, right? It would probably not be good to keep you too much, but maybe as a last word, we want to thank you a lot for coming. This is the first time we have been hosting a meetup
in this space. So we would value your feedback. If you think that we could do something better, or generally, if you have any feedback, let us know. We will be happy to host in the future for sure as well. We are, as mentioned, specializing in data and cloud engineering. We are also learning. I think we're happy to engage in the conversations. If you want to have a chat, please do. And yeah, please enjoy the pizzas. If you want to take some pizza home, feel free. And yeah, thanks a lot for coming today.